Hi, my name is Cristiana Antunes, and I'm going to present the work Inclusive Art Stories, an inclusive storytelling activity with an emotional robot. Storytelling is a crucial activity in children's development, as it helps to promote several skills, such as language expression, collaboration, emotional intelligence, among others. Despite the numerous storytelling systems that can be found nowadays, most of these are not designed to be inclusive or accessible to children with visual impairments. In fact, most of the technology that children with visual impairments have access to in schools are not built to be inclusive. They are built or designed to be accessible, which creates a barrier between children with visual impairments and sighted children who often share classes. Despite the scarcity of inclusive storytelling systems, interactive storytelling activities have a huge potential to reduce exclusion in mixed ability settings, as this type of activities often promote collaboration and kinship. However, these activities need to be accessible and inclusive, which can be attained through multimodal stimulation or feedback. Based on this, we decided to design and implement Inclusive Art Stories, which is a prototype composed of a multisensory environment and a robot that has multimodal behaviors. Through this prototype, a set of mixed visual ability children can work together in order to co-create a story. Taking into consideration previous research that showed that emotionally expressive robots tend to promote learning, play, and even promote children's emotional intelligence, we decided to integrate this strategy into our system by providing our robot with multimodal emotional behaviors that take the form of changes in light, color, movement, and sound. To do this, we decided to use the Ozobot Evo robot, as this is able to execute this type of behaviors and given its non-anthropomorphic shape. We then designed and implemented 4 behaviors that match 4 basic emotions, more specifically, anger, happiness, sadness, and fear. I will now briefly show you these behaviors. So for anger, we decided to represent it through red lights, rapid and abrupt movements, and grunting sounds. For happiness, we decided to represent it through green lights, a dance-like movement, and laughing sounds. In turn, sadness was represented through blue lights, very slow movement, and crying sounds. And last, fear was represented through purple lights, a very shy motion, and screaming noises. Regarding our multisensory workspace, we decided to split it into 4 different small rooms, which have unique colors and textures. And based on the color of the room, the robot would execute one of the 4 behaviors. In addition to having different textures and colors, the rooms also have unique environmental sounds, which all resemble a school context. These sounds and the robot's behaviors are triggered by off-the-shelf Bluetooth buttons that are placed in each one of the rooms, as you can see in the picture. In order to make the activity more immersive, we also provided children with some small toys that they could use when creating the story. After implementing our prototype, we conducted a user study in order to evaluate it. This user study was conducted with the objective of answering 3 research questions. The first research question is focused on the effectiveness of multisensory environments and robotic devices in inclusive storytelling experiences. The second question is more focused on the effect of the robot's behavior on the content of the stories produced, while the third question is focused on the strategies and what kind of roles did children take throughout the activity. Our user study occurred in Portuguese schools, where 16 children tested our prototype. Half of these children were visually impaired, while the other half were sighted children. Taking into consideration the collaborative nature of our activity, we decided to split children into 8 mixed visual ability dyads. Taking into consideration that we wanted to observe the robot's behaviors in the overall activity, we decided to conduct a within subjects user study in which each dyad tested 2 conditions. One in which the robot would have no behaviors, and another one in which the robot would have the 4 behaviors I showed previously. In order to reduce the learning effects between conditions, we also decided to encapsulate the robot inside a 3D printed model so that that was unique to each condition. In each test session, children had time to explore the workspace, the toys, and the robot, and then they were instructed to co-create a story that should include the character portrayed by the 3D model. After conducting all the tests, we observed and annotated the video recordings of these and evaluated some metrics. These are the most important ones for us, which are the interaction and manipulation of the robot, the content of the story's emotional connotation, the ideas exchange, and the children's roles throughout the activity. Through these metrics, we were able to gather some qualitative and quantitative results that helped us answer our research questions. Regarding the first question, which focused on the effectiveness of multisensory environments and robotic devices in inclusive storytelling experiences, we came to the conclusion that our system was able to offer autonomous interaction, mainly because this was done through touch, which was common to children with and without visual impairments. Additionally, we were also able to engage both children, regardless of their visual acuity, due to the various dynamic auditory, tactile, and visual components, which led to an even participation as all children were engaged and could easily participate through the button control system. Regarding the second question, we did not find any difference in terms of the influence of the robot's behavior in the content, in the creative content of the stories created. However, we did find a difference regarding the emotive elements, as children included more emotive elements in their stories when the robot displayed emotional behaviors. This led us to believe that the presence of these behaviors is crucial for children to make this emotional exploration in the activity. Regarding the third question, which focused on the strategies and roles, we found that the most common role was a co-creator role, while the most followed strategy was to co-create a story while they were exploring the workspace, as well as asking their peers for help whenever they needed something. Besides answering our research question, we also thought that it would be helpful to share some guidelines that could help others when designing inclusive systems. So, and based on our work with this project, we really believe that having multimodal behaviors for robots is crucial to engage all children, regardless of their visual acuities, as this makes the robot perceivable to all of them. We also believe that multisensory workspace is very important to keep children engaged and to give every child equal opportunity to participate. And lastly, we also believe that it is very important to think about the interaction method of the activity, as this must be common to all children so that a balanced participation can be achieved. In our case, this was attained through the verbal nature of the activity, but also through the Bluetooth buttons that allowed children with and without visual impairments to easily interact through touch with our system. Besides offering an opportunity to reduce exclusion in mixed visual abilities settings, our project also raised awareness in children to their peers' abilities and difficulties. It also promoted their emotional intelligence and spatial orientation. We also believe that our system can be applied in different settings, or specifically in a teaching setting, or even in a therapy setting, given that the spaces that are explored in our workspace can be easily changed and adapted to expose children to new realities and new situations. So given the flexibility of our system, we really think that it has potential to be used in different situations and to help children improve several skills, but in an inclusive way. So thank you very much for your time. And if you have any questions or would like to get more information, please don't hesitate on contacting us. And thank you.